Hi, my name is David Follis, and I work for IBM in Poughkeepsie, New York. Today I'll be talking to you about WebSphere Application Server for zOS, what it is, how it's the same and different from WAS on distributed platforms, and why you might want to choose zOS as the platform for WebSphere Application Server. The charts in the presentation, much of the script, and all the production work is provided by Don Bagwell. This is the agenda for the presentation. We start with the WAS is WAS message because it's important to first establish that WAS on zOS is, from an application perspective, no different than WAS on any other platform. That allows application development to be centered around the open standards using common tooling. However, the implementation of the open standard specifications have elements that are platform specific. That will set the stage for discussing how WAS on zOS takes specific advantage of System Z and zOS. That's our core message, common and consistent at the application layer, platform benefit on System Z and zOS. The value statements for System Z and zOS are not always fully understood. Before launching into a discussion of how WAS zOS takes advantage of the platform attributes, we must first review what those attributes are and why they are of importance. This section is labeled the cornerstone because that's exactly what System Z and zOS represents, the cornerstone of the foundation on which our whole message rests. The next section goes into some detail on how WAS on zOS takes advantage of the platform attributes described in the cornerstone section. This is where we will illustrate the value of WAS on zOS with respect to the value provided by the System Z and zOS platform. The section on WAS on Linux for System Z is offered for completeness. While there are benefits to running WAS on Linux for System Z, the list of benefits is not nearly as long as those derived from WAS on zOS. The section on disaster recovery and high availability offers a summary of a key element of System Z and zOS, the issue of successful disaster recovery processing, and the topic of availability and how System Z, zOS, and WAS on zOS contributes to the HA story for applications. The topic of cost is provided because there is considerable misunderstanding about what WAS on zOS costs and how to effectively evaluate that cost compared to WAS on other platforms. Here we establish the key starting premise of WAS on zOS, common and consistent with WAS on any other platform supported by WAS itself. This is the core of the WAS is WAS statement. WAS itself is dedicated to the idea of an application-serving platform built around Java and commonly accepted standards. The chart provides a very brief listing of some of the standards supported, with a pointer to the Info Center article that provides a more complete listing with details. The curved gray line represents a layer of abstraction between those open standards, common and consistent across all platforms, with the platform hardware and operating systems on which WAS is supported. Having established the principle of WAS is WAS at that open standard specification line, it's then important to establish why that's of value. If WAS on zOS required application development and application tooling unique to zOS, then the value statement of WAS on zOS would be lessened. But because WAS is WAS, the benefits outlined on the chart become operative. Applications are written with respect to the standards, not the platforms. Tooling is common across all the platforms because the tooling generates platform-neutral code that operates against the standards, and because of that, applications are portable across platforms on which WAS runs. This allows application development to take place on, say, a Windows workstation, then be promoted to a middle-tier platform for test, and finally promoted up to production on more robust platforms such as System Z and zOS. Another benefit of this approach, adopted by IBM starting with WAS version 6, is the convergence of release schedules across platforms. It used to be that WAS on zOS releases lagged by several months, but that's no longer the case. Now new versions, new releases, and even fix packs are released concurrently for all platforms. After all this talk about how WAS is WAS, you might think that there's no difference at all between WAS on the different platforms. But that's not true. There are differences. It's just that those differences manifest themselves below the Open Standard Application Specification line. That's where the function called for by the Open Standard Specifications is implemented. A large majority of WAS code is in fact common across all platforms. It's just that some is unique for each platform. There's a lot of Java code involved with WAS, and that Java code is common across platforms. The code that's unique, based on platform, is somewhere less than 10%. WAS on each platform has at least some code unique for that platform. WAS for Windows has some code unique from WAS for Linux, which has some code unique from WAS for AIX. Of all the platforms, WAS on zOS has the most unique code. The reason WAS on zOS has the most unique code is because zOS has more platform functions that can be taken advantage of than other platforms. zOS has been in existence for a very long time, and it has a very rich set of functions available for middleware such as WAS to take advantage of. That sets the stage for the rest of this presentation, which involves first a review of the features of System Z and zOS, and then a review of how WAS zOS takes advantage of them.